Hello guys, welcome to a different session. Today we want to look at how questions are phrased in electrochemistry. In the previous video, if you looked at the previous video that we had over electrochemistry, we looked at the introduction to electrochemistry, we looked at the principles that govern electrochemistry, we looked at words like reduction, oxidizing agent, reducing agents, and different kind of words that accompany the topic of electrochemistry. But we want to look at questions. How do you deal with the cell potentials? And the question that we want to look at here today is this question here. Don't know if you're able to see from here. I hope it's very clear. This question right here. It's saying calculate the cell potential of the following redox reaction. Well, we've been given the copper 3 as 0.05 molar, the copper 2 as 0.03, the tin 2 as 0.015, and the tin 4 as 0.02 molar. So we've been given the concentrations of these half reactions. Remember, this is a half reaction. And then because we've been given everything that is here, and the overall reaction has been given, how do you work out? How do you find the potential of the following redox reaction? How do you work it out? And in the end, we've been taught to say the EC of this chemical reaction has been given as 0.617 volts. So how do you find the cell potential of this half reaction? So the question is very easy. Remember in the previous introduction that we had to electrochemistry, we talked about different kind of equations. We talked about the equations that govern a chemical reaction that is at equilibrium. We talked about a chemical reaction that govern equations that are not at equilibrium. And from the look of things on this chemical reaction that is here, you know that this chemical reaction is not at equilibrium. So it's a straightforward kind of equation. And the formula we're going to employ here to find out our values is this formula here. We'll say our E, so let me brighten it up a bit so that we're able to see what I'm doing here. Our E will be equal to the E cell value minus the 0.0591 divided by 2, then log Q. So the log Q here is representing the concentrations of the products over the reactants. And we've already been given everything here. We've been given the value of E as 0.617. We've been given the value of the Q. The Q, what I mean by being given the value of Q, I mean that Q now will be equal to, you know that the product, we have the product of that chemical reaction, and we have the reactants of this chemical reaction. And on the side of the product, we've got two things here. We've got the tin 4 here, and we've got the copper 2. So this is going to be the representation of our products, because in a chemical reaction, you can identify to say these are the reactants and these are the products. So the SN4, which is the tin 4, and the copper 2, these will be our products, and then these will be our reactants. So we're just supposed to replace whatever was being given in that chemical equation. So we know that the value of E is 0.617 volts. That is going to give us minus 0.0591 divided 2. So this value of 2 we're talking about here, remember from the introduction to electrochemistry, is the value that balances up the two half reactions. What's the value of that ratio that is balancing up the two chemical reactions? What value is that? So from the look of things, you can know that this value of 2 was the value that was balancing up the chemical reaction that was given in this equation. So you can look from here, you know that this value right here, the value of 2, the mole ratio of 2, is the value that was balancing up the number of electrons that are in this chemical reaction. So you can see that there's a 3 here, the 6 electrons here, how many number of electrons are here? That is a 2 times 3. That is going to give us a what? 4 number of electrons. So now to put up everything on paper here, this is what we're talking about. Let me do that. What I'm talking about is this. You know, if I get one reactant from the reaction, and I'm going to get copper, I'm going to get copper 3 there, then the copper 3 will be equated to the copper that is on the side of the product, which is a copper 2. So now, remember how we're balancing up these chemical reactions. We have two atoms of copper, of two atoms of iron here, and we've got two atoms of iron here. How many electrons are on the side of the reactants? That's 6, because the mole ratio also affects the number of electrons that are here. This is going to be 2 times 3, we're going to be given a 6. And this is going to be 2 times 4, we're going to have a 4. And what's the difference between 6 and 4? That is 6 minus 4 is going to give us a 2. Now these 2 are the number of electrons that were transferred. And where are we going to add these 2? Is it on the side of the reactant or on the side of the product? We are going to add these number of electrons on the side of the what? On the side of the product. Because on the side of the product, that is where we have more electrons. And you know an electron is negatively charged. And when you add it there, it's going to reduce the number of electrons on the side of the reactant so that we can have equal number of electrons in this half reaction. So we're going to have a 2 here, 2 Fe. This is a 3 plus. Then how many number of electrons? That was the difference that we found. That is going to give us 2 Fe. That is a 2 plus there. So you know that how many number of electrons do we have on the side of the reactant? That is a 2 times 3, going to give us a 6. A 6 minus the 2 number of electrons that are here are going to get a 4. 6 minus 2 is a 4. And on the side of the product, that is a 2 times 2, are going to get a 4. So you know that on this first half reaction, the number of electrons on the side of the reactants are balanced on the side of the products. And the number of atoms, the atoms of iron, are balanced on the side of the reactants and are balanced on the side of the products. How about for tin? So on the tin, we have tin 2 being given tin 4. Okay? How many number of electrons do we have here? We have 2 number of electrons here. And on the side of the product, we have 4 number of electrons. The difference there is a 2. We're going to add the difference on the side that has got more number of electrons, and that is on the side of the product. How many electrons? 2. Are they balanced? Yes, they are balanced, because this is a 4. A 4 minus a 2 is going to give us a 2, and then the 2 on the side of the reactant is going to balance up with the 2 on the side of the product. So this is how you balance these chemical reactions. And you know to say these chemical reactions have been balanced up. There's a 2 here and there's a 2 here on the side of on the 2 half reactions. So this value of the 2 is the mole ratio that is balancing up the 2 half reactions. And when we put them together, we're going to end here on this overall half reaction that was given. So the value of 2 here is a 2, because that is the mole ratio that is balancing up the 2 half reactions. So I think you get that. So here, the value of N is equal to 2. How about the value of Q? So there's a log here. The Q, I was saying, we've been given the molar concentrations of the product and of the reactants. So you should know that here we're targeting the product over the what? Over the reactant. Great. So let's see what we have in this equation that is here. So we're having something like this. So let's come here. We know that the E cell was already given, which is 0.617. That is minus 0.0591. And the value of N is a 2. That is going to give us log. The product, what we have on the side of the product. On the overreaction, what we have there is we've got 2 atoms of iron and 1 atom of tin. So how am I going to arrange everything there? This is the arrangement itself. We're going to have something like that. I'm going to open my brackets, and then after opening my brackets there, I'm going to add the product. The products that we have there is tin 4. Everything was already given in the question. If you check out the concentrations of tin 4, that is 0.02. So that is 0.02. So you should check out everything there. We've already been given the concentrations. So that is 0.02 times the iron was already given, but the iron has got a mole ratio of 2. So that mole ratio of 2 becomes an exponent for this concentration. So it's going to be power to 2, 0.030. So this is going to be a power 2. So these are the products over the reactants. The reactants, we also have the atoms of iron and we also have the atoms of zinc. So you're also going to indicate them there. And if it happens to say that chemical reaction that has been given here, or this half reaction, is having the more ratios that have powered to certain numbers. Like there's a more ratio of 2 here. You can check that there's a more ratio of 2 on the ion, and there's a more ratio of 2 on the side of the product. They become exponents for these concentrations. So on the down part here, I'm going to have 0.05, which is going to be raised to a power of 2 because the ion there is raised to a power of 2 times 0.015. So now we find out what value of the E are we looking for here. Remember, we are finding the cell potential. That value we were given there in the question was the E cell of that chemical reaction. But what is the overall cell potential of this half reaction? That's what we're finding here. So after doing your math here, you're going to have 0.617 minus 0.0591 divide by 2. Then I'm going to say log of what we're going to have here, which is going to be a value of 1.08 times 10 to the power negative 4. So after doing your math here in your calculator and everything, the final value that you must have as your value of the E cell should be 0.5 volts. And therefore you're done. So this is how you work out this question. It's very easy. So one of the basic principles that I want you to walk away with here out of this lesson, I want you to know how you're supposed to use formulas. And I want you to know that the only distinction or the only thing that makes you different from that A+ student are the number of questions that you do before the exam. So make sure you practice a lot of questions, because remember the saying, practice makes perfect. So let's practice more questions, let's study a lot and see how best we can attempt as many questions as we can. So guys, this is the lesson I had for you. Hope you enjoyed it, and I look forward to the next lesson. This is Blessings Pomborok. Thank you.